You start? Okay. All right, guys. So we're going to begin the nervous system. The nervous system. The nervous system. And in order to understand the nervous system, we have to break it down into structure and function. So we break down our nervous system into structure and function. Structure and function. So the structure of the nervous system, we have to understand how do the medications on the nervous system work by first of all breaking down the nervous system. So the nervous system is broken down into two compartments. One compartment is responsible for integration, processing, control. One compartment is responsible for integration, processing, integration, processing, and control. Integration, processing, and control. And another compartment is responsible for bringing in information, bringing in information, and sending out information in the form of input, input, input. So you have an input that is going to the integration, processing, and control center, and you have an output, an output information going out. So what does that mean? If you make a phone call to the police, you call 911. You tell the 911, that is the integration center. That is the processing center. They process your call. Do you need the fire department? Do you need the police? Do you need the ambulance? And then they send out the correcting response based on the input. So if you call, you want the fire department, they send the fire truck. They're not going to send the ambulance or the police. If you want the police, they're not going to send the fire department or the ambulance. If you call and you want the ambulance, they're not going to send the other two. So this 911 center must get an input. If it has no input, there will never be output. So the same way your nervous system will receive input. It's too hot, it will send output. Let me sweat to cool down. You are so cold, then the nervous system will say, let me shiver to warm down. So you will see the input and the output are always the opposite, are always enemies. If the input is high, the output will be low. If the blood sugar is high, the output will be to secrete insulin to bring down this blood sugar. If the blood sugar is low, your body will secrete from the pancreas glucagon to bring up the glucose. So here you see there is sensation. So the input is always sensory. The input is always sensory. And the output is always motor. The output is always motor. The input is sensory and the output is motor. The input is sensory because it's dealing with a receptor, a sensor that will sense something. There is a chemoreceptor that will detect some chemical. Hyperoxemia, hypoxemia, hyperglycemia, hypoglycemia, hypercalcemia, These are chemicals. Calcium is an electrolyte. It's a chemical. Glucose, that's a chemical compound. So to detect the presence of these chemicals, we need chemoreceptors. Then we have other type of receptors like a thermoreceptors. Thermoreceptors will say, is it too hot? Then your sweat glands will secrete the sweat. The thermoreceptors will say, it's too cold. Then your skeletal muscles will shiver. So these are known as thermoreceptors. There are also mechanoreceptors. These are mechanoreceptors. These are receptors for stretch sensation. They sense the stress. And we have nociceptors. Nociceptors. These are receptors for pain. But in the end, who do the receptors work with? Do they work with the input or the output? Always the receptors are communicating an input signal. The police 911 is not going to call you and tell you, is everything okay? No. The police is going to call the effector. The effector. The effector is going to be the organ or the gland that will do the effect. So the sweat gland is the effector that did the effect of sweating. Did the effect of sweating. Do you understand? So the police officer is the effector who came to resolve the assault, dispute, or the robbery. The fire truck is the effector who's gonna come in and stop the fire. The ambulance is the effector who's gonna come in and save the life. So the effector is the one who will do the effect. In the body, the pancreas is an effector because it secretes insulin to bring down high glucose levels. The sweat gland is an effector because it causes the sweat to be secreted and cool you down. The heart is an effector because it receives message to increase heart rate because this person is running, we need more blood. So if you do an effect, you are an effector. So the motor response is always going to target the effector. That's why we call the motor neurons, we call them efferent. We call them efferent neurons. We call them efferent neurons. While the sensory are called afferent neurons. Afferent neurons. Remember last week when we said all we need to say is polar. We say polar, you immediately know that is lipophobic and hydrophilic. Remember? You say one word, you know the other two. Same thing here. You say input, you know it's sensory and afferent. You say output, you know that's motor and efferent. But that still didn't answer my question. How do we break down our nervous system? We broke it down into blue and red. You're either blue, you're the 911 headquarters, you receive phone call and you send out calls to the effector. You receive phone calls from a receptor, you are a receptor. You are a receptor. You give information, you tell, right? You told if it wasn't for you, they would have never told there's fire there, there's ambulance needed, there's police needed. So you're the one, you're the receptor. So here there is a division of the nervous system that is red, sending in or taking out. Then there is a blue division, is the headquarter, the center, the precinct that is responsible for processing, integration, and the control. So What do we call the blue one now? I'm sorry? Excellent. So the blue one is the central nervous system. Central nervous system. Central nervous system, or the CNS. And it is divided into two different systems. Somebody said peripheral. The central nervous system is your brain. Your brain. Where do we find the brain? In the cranial cavity. In the cranial cavity. And where do we find the peripheral? Peripheral. Where do we find the spinal cord? We find the spinal cord in the vertebral cavity. Vertebral cavity. And those two are blue. Those two are computers. The spinal cord, just because it's long, it doesn't mean it's not. So it is central nervous system. It can integrate lower body movement. You know, the knee jerk reflex has nothing to do with your brain. Yeah, from a spinal cord. So you tap on the patellar tendon. Who's going to send information to the spinal cord? Sensory input afferent or output motor efferent? When you tap with a hammer on the patellar tendon, and there's a stretch receptors on the patellar tendon. So that's going to be afferent sensory input to the spinal cord. Then the spinal cord is going to generate an output to withdraw, to extend your leg and move it. So that one had nothing to do with the brain. When you hit the patellar tendon, it didn't go up to the brain, it just went to the spinal cord. So that's blue, that's central. So we have the central nervous system. That's one division, all blue. Then what do we call the red? The peripheral nervous system. What do we call that? The red. What do we call the red? Yeah, that's the peripheral nervous system. Excellent. So red is the peripheral nervous system. And the peripheral nervous system is divided the same way the central nervous system is divided into the brain and the spinal cord. The peripheral nervous system also is divided into, please don't say the brain and the spinal cord. It is divided. No. We just write it right there. Yeah. The peripheral nervous system is divided into sensory and output. Very good. So the peripheral nervous system is divided into sensory and motor. And we said one word is enough. Sensory means input and sensory means input and afferent. And output means afferent and motor. You got to know the three. One is not enough. Knowing polar is not enough. You got to know polar is hydrophilic and lipophobic. Knowing one is not enough. Okay, so now we divided. We divided the nervous system structurally and functionally. So structurally, we divided it into the central nervous system and the peripheral nervous system. We divided our central nervous system structurally and functionally. We divided the nervous system structurally and functionally. We divided the into structurally into central nervous system and PNS, peripheral nervous system. Functionally, we divided it into what? Integration, blue, integration. We divided it into integration, processing, and control. While the other the functional classification is integration, processing, control, or sensory, input, afferent, or motor, output, efferent. So that structure, that's function. We said that structure doesn't end there. Central nervous system is divided into the brain and the spinal cord. And the peripheral nervous system is divided into afferent and efferent. Okay, now there are other classifications. So where does the sympathetic nervous system come from? The parasympathetic nervous system comes from. So that comes from, who do we getting the information from? So you know your body has different tissues. You have soft tissue known as a visceral tissue, and you have tough tissue known as somatic tissue. So we have two different types. So now, even though we have input, sensory, afferent, but you know now the police get a phone call for ambulance. It's not enough. Is the phone call coming from Brooklyn, Queens, or Staten Island? So now you got to know where it's coming from. Just you need an ambulance is not enough. Where is the ambulance needed? Same thing in your body. Getting an input signal is not enough. It's coming from where? Is it coming from soft tissue like the lung, the heart, the kidney, the liver? That's called visceral. Visceral input. Visceral input. So afferent, we said that afferent is input, and sensory. Afferent, input, and sensory. While efferent is output, and motor. So you will get afferent input, sensory, from soft tissue known as visceral tissue, and or from tough tissue known as somatic tissue. Because everybody has a signal, right? It's not like the bone tissue doesn't feel pain. The bone tissue, because it's so tough, doesn't feel temperature. It does. So the soft tissue feels temperature, feels pressure, feels pain. Tough tissue also feels pain, feels temperature, feels pressure. So you have two kinds of sensory. Sensory from soft tissue, known as visceral sensation, or from tough tissue, known as somatic. Same thing with the motor, the outer response. Where are we sending the police to? What are we sending the ambulance to? What are we sending the fire truck to? Are we sending it to Staten Island or to Queens? Same thing. The output is going where? The motor output. Is it going to a soft tissue? That's known as visceral, and somatic. So the sympathetic and the parasympathetic, they are always motor. They're always motor, and they are responsible. So the visceral and the somatic, they are systems where we get a motor response like squeezing a sweat gland. That's visceral or somatic. Sweat gland. Visceral or somatic. Sweat gland, is it soft or is it tough? Visceral is soft tissue, such as lungs, such as kidney, such as heart, and there is somatic. Somatic is tough tissue. And tough tissue, somatic, an example of that would be cartilage. Cartilage is cartilage, and bone and muscle. So if you're going to have a motor, if you're going to have a motor output to the visceral tissue, that is known as the autonomic nervous system. Here, if you are sending out an output, if you're sending out an output to some soft visceral tissue, then that one, because you know, soft tissue sensing sensory signal and receiving motor output. Tough tissue sending a signal, receiving a motor output. But soft tissue that is getting out an output, that is going to be known as the autonomic nervous system. That is divided. So this is the autonomic here. You know, you can have soft tissue sending a signal and soft tissue getting motor response. You can have tough tissue sending a sensory input and tough tissue getting a motor response. But the soft tissue, when it's sending a motor response, that is known as the autonomic nervous system, which is divided into sympathetic, fight or flight, and parasympathetic. And today we're going to be going over the sympathomimetics. You know, last week we agreed that doorknob, if you put on it a copy of the key, the doorknob is not going to say, oh no, this is not the master key from the custodian. It's going to open. So we're going to have sympathomimetics. Sympathomimetics, they mimic the actual key. They mimic the actual sympathetic innervation. They mimic the actual sympathetic innervation. So we're going to get into that. This here is enough. So later when we talk about the drugs, how do they work? Benzodiazepines, barbiturates, they depress the central nervous system. You know where that is. Do they work in blue or red? I haven't talked nothing about barbiturates. I haven't talked nothing yet about benzodiazepines. But just because I told you they depress the central nervous system, where do they work? Blue or red? Blue. So that's very good. So now you have a roadmap. So when we are now talking about in the lecture about the different types of medications, you know where they're going to work. The last thing I need you to know is that when it comes to the medications of the nervous system, they are either plus or minus, pressing the gas or pressing the brake. So it's either you're hyperactive, we want to press the brake, calm you, sedate you, hypnotics. So you can tell from the name, sedating medication, sleep. So they press minus. So do they press the brake or press the gas? Press the brake so you can depress. But if somebody is too depressed, do we make them even more depressed, or we press the gas? Okay, but we don't say gas. We don't say brake. We say stimulation, and we say depression. We say excitation, and we say inhibition. So we have two types of neurons. Neurons that are excitatory. Once they fire, they cause excitation. So there are excitatory. There are first is inhibitory minus synapses. These are known as the GABA. These are the GABAergic neurons. What does GABA stand for? Gamma amino butyric acid neurons. When these are on, you get depressed. So these are the ones we give to patients who are really, really excited. And the opposite is the stimulatory. That's the plus. Plus. So the plus is the glutamate. An example of that is glutamate. So glutamate is you give that to patients who are depressed so that they can get excited. These are excitatory. Excitatory. And they have glutamate, not GABA. So when you hear GABA, you remember immediately we're pressing the brake, we damping things down. When you hear of the glutamate, you know we're exciting things up. So as we go over the lecture slides, things are going to make more sense. Okay, so this is now the introduction that's gonna help us, put the medications in perspective. That's what you're gonna. So now you heard it. So you're gonna go home, just watch the video again, summarize it, post it up for full credit, and then you're gonna see me ask a question on the exam, something like that. Efferent, is that input or is that output? I'm gonna ask you. Somatic, is that I'm going to ask you the autonomic nervous system. Is that dealing with a visceral tissue or is it dealing with the somatic tissue? So what I've just been mentioning now, you heard it. Go to home, listen to it again, and then we're going to go over the slides now. Okay? So thank you so much. Please give a round of applause to your classmate. Thank you.